Good morning, everybody, and welcome to ACT-IAC Network and Telecommunications Community of Interest. Today, we're going to discuss the powering of AI and the government applications and the critical role of the network and data communications in being able to support the AI. First, I want to introduce myself. I'm Richard Zelkwitz. I'm the industry chair of the Network and Telecommunications COI. Other than that, I'm retired after 45 years of work in both government and industry. On the slide, it shows you what the mission of the COI is. I'll just briefly state what I think that the scope is very, very broad. It has anything to do with transmission of signals from the point of collection until where the ultimate end use is. It could be a person, it could be a data center, et cetera. Below that are some projects that we've done in the last 2 years. TDM retirement is actually getting ready to be published. The NGNI task force that we're working on with the acquisition COI, that's on hold because GSA has pulled back some of their people in supporting ACT-IAC initiatives. And then the last one is we're starting this year, it should be done by June 30th, is the modernizing the federal networks and from the campus and beyond. With that, I want to introduce Tom Timmins. Tom Timmins is going to be our moderator today. He is the host of the Federal Drive on Federal News Network. So Tom, I turn it over to you.
Okay, thank you very much. Yes, I am Tom Temin of the Federal News Network for at least another couple of weeks anyhow. I really like this topic today because all of the panels, and I've been on a bunch of them lately and moderating all over the place, are talking about artificial intelligence, talking about the next generation of IT modernization, et cetera, et cetera. But there hasn't been a lot of discussion that I've heard, and there probably should be more, about the need for the infrastructure to support all of this. So we have a really great panel of people in the industry today that know this stuff, and we're going to get right to them and get right down to our questions. Let me introduce the panelists briefly for you. Joining us is Jim Gwiazda. He is the Vice President of Public Sector at supplier Equinix. Jim, good to have you with us. We also have Jan Niemiec with Google, where he is the Managing Director of National Security for the Google Public Sector. Google's a cloud supplier, in case you didn't know. And we also have Campbell Palmer. He's Vice President of Solutions Engineering and Architecture for the Public Sector at Lumen. Gentlemen, good to have you with us this morning. And let's get right to it, and we'll just go around, and we'll start with Jan, because that's who's the next one on my screen, and then we'll go on to Campbell and Jim. But the growth of generative AI, not just AI, but generative, has really caused this explosion of investment in the data centers. But that's because, in part, so much traffic is caused by generative AI. So what do you see in the rapid growth of generative AI and how it is driving fiber, the need for more bandwidth, more robust networks? It seems to be kind of a crucial need. Jan?
Yeah, thank you very much, Tom. You couldn't be more spot on. But first, I want to say thank you, everybody, for having me. And thank you for these great partners that we have online with Google today, Lumen and Equinix, Jim and Campbell. Really looking forward to the discussion. So yes, at Google, we talk a lot about generative artificial intelligence. Those who might not know, Google is the author of the Transformers white paper back in 2017, of which a lot of the techniques for artificial intelligence was developed from. And those techniques are great, and they've evolved AI into this generative, and now we're going into agentic, if folks out there have heard that type of terminology. And all that has to run on something. It turns out that artificial intelligence is very, very compute hungry. As seen with big partners like NVIDIA and suppliers of chips. Google also produces AI chips called TPUs, tensor processing units. But again, that compute and that persistence only works if we have the connectivity. And that connectivity is anything from last mile, it could be from a cell phone or endpoint device into the network, or it could be between the large data centers. and the demand is spiking massively. Google itself is investing heavily alongside of partners in order to build a global resilient infrastructure that can handle this new demand that's being thrown at it. But Google alone cannot do that. We rely heavy on many industry partners, of which two of them are here, Tom.
Okay, well, let's move to Campbell. Maybe tell us briefly what Lumen exactly does, and then talk about the need for what's next in terms of bandwidth and network infrastructure for AI, generative AI.
Sure. Thanks, Tom. And I echo Jan's sentiments. It's great to be here. I appreciate the invitation and the opportunity to speak. Working with partners such as Jan at Google and Jim with Equinix, it's been vital to the overall explosive growth that we've been seeing inside of Lumen. We made a decision and a position to strategize our network infrastructure investment to really collaborate and partner with AI developers and integrators across the entire market space. Certainly with Google's platforms being one of the top leaders, we're seeing there is a massive amount of data that transmits across the network infrastructure that we're providing. And so we're making significant investments, both from new fiber types to allow for this ultra low latency functionality and capability, but also for capacity. So if you think about AI and how it operates, and certainly between data centers, and as Jan was referring to with the GPUs inside of a single infrastructure, there's a massive amount of data and information that conveys between the back ends of AI as it's basically building out its own modularized instance of data formation. So that's a huge amount of capacity that's required in order to be able to support just the AI generative component. Then you have the front end, right? It's the actual users that want to be able to access the AI. So the benefits that we're seeing is the investments that we're making in providing that connectivity and that resiliency between the data centers allows for also the added benefit of the end users to be able to leverage that network from the front end, utilizing different means of network connectivity that we're able to allow for those users to be able to get information from the AI developers.
Yeah, that does sound like a lot of crisscrossing traffic, and I want to get into some detail there in a few minutes. But Jim, again, tell us a little bit about Equinix and what your take is on this bandwidth requirement.
Yeah, absolutely. Thank you, Tom, and thank you, ACT-IAC, for hosting this type of forum, and Tom for helping to moderate. And as both Jan and Campbell mentioned, there's close alignment between our organizations because this is such an important topic, not just for us from an industry perspective, but also in supporting agencies. And for those who don't know, Equinix is one of, if not the largest data center and digital infrastructure company in the world. And when I think about the rapid growth of generative AI, it's really pushing data centers, not just Equinix, but all data centers, to their limits in terms of infrastructure capacity and scalability. And as AI-driven applications kind of continue to grow at these unprecedented levels, there are increased compute power demands and data flow requirements. And I think there's really 5 key challenges that we need to rise to in order to meet this demand. And the first is around high bandwidth and fiber connectivity requirements. Campbell was talking about this a moment ago, but these generative AI workloads, they require massive amounts of data transfer between nodes, models, and systems. And I think this is necessitating a significant increase in fiber connectivity, whether your data center is on-prem or off-prem. The next kind of key challenge and factor to be mindful of is around power and cooling limitations. I think these are compute intensive requirements, and they generate a substantial amount of heat. And advanced cooling is required to support those. So, your grandmother, your grandfather's data center, isn't necessarily built to support these high density requirements. The third is around cost and complexity of scaling AI infrastructure. I think there are other things you need to think about, like sustainability pressures. And then finally, around global expansion and latency concerns. Now, not all agencies have a global mission, but those that do require this distributed data center architecture in order to support that. And latency is really important, a factor in terms of these mission critical applications, especially when you're talking about at the edge.
And I wanted to return to that question that Campbell brought up too, is the latency question. And you always want low latency in general. That's a good quality of life to have. But in general, you think of latency for where there is a input and a response needed, such as a customer experience or delivery of service, say, to a constituent, or if you're working on an internal enterprise application and you need an answer for someone or for something, then you don't want latency, or if you're in a tactical situation. In AI, though, what are the types of applications where latency is important, where low latency is important? Because if you're doing research or generating some kind of something or other, does a few seconds really make any difference? And we can all jump in on this, but I threw it at Campbell first.
Oh, okay. So from a transmission standpoint, yes, I would say that latency is crucial, and making sure that there is that you have seamless interaction between the data center environments as data seek is taking place. When you think about the limitations of latency, really that will create huge limits on how quickly you're able to transmit data from one endpoint to another, which is really the epicenter of how you're trying to create the regenerative AI environment to establish the workloads that are split between the data centers. So the closer you can get between endpoints, certainly the better performance and the higher outputs that you'll be getting from the actual data collection and making the solutions become viable and certainly be available. So we're heavily reliant on our partners with the improvements that we're seeing in basically speed of light through glass. And just that mechanism of decreasing that refraction within the glass, it will certainly decrease significantly that latency that you're going to experience, that will allow for these data centers to actually feel like they're closer than ever. You know, historically, we've seen many, many milliseconds of round trip delay that really have extensive impacts with overall throughput. The more we're able to minimize that, the higher the throughput that you're going to have, and the more cognitive the two AI environments between data centers are going to be able to operate.
There's almost a fluid dynamic principle there, that a little tiny pinch at one point can really back up things as you keep
Absolutely.
going. Fair to say? Anyone want to jump in on that?
Yeah, Tom, I could jump in just from a use case perspective. I guess when you look at user experience, like you highlighted, um, as other industries can now have easy access to AI, and that's what's really happened with the agentic. If you look at, for example, say the medical community, where those of us have interfaced with doctors many times, and sometimes they used to write down and then they started typing into a computer, and now the ability is there, and some of the hospitals are rotating to where the meeting is recorded, right? And there's an AI agent there that helps the doctor summarize all the notes and automatically put that into the chart. That only works if that responsiveness is there. If you got to wait 20 seconds for it to summarize it and put it in there, the user experience for the doctor in this case is low enough that they're not going to adopt the technology, right? And the usefulness kind of goes away. So that really needs to be there, that responsiveness and that type of scenario. And that's a direct, and what we see is like industries can directly interface with AI with, and not as much IT professionals, right? So the industries kind of come directly into it. That would also apply to things like manufacturing, right? Where manufacturing might have time critical scenarios going on the production line. And if you're going to have those folks that are operating interface directly with AI, if that latency is too long, right, they're not going to adopt the technology. It's not going to bring the usefulness there. I don't know if that helps clarify and target some of your question.
Sure.
Just to add on what Campbell and Jan said, I'll speak from a data center perspective around the low latency aspect of it. I think, Tom, it depends on the application, right? So if it's a training model, then perhaps it's not as latency sensitive as, something that you're trying to do from an inference standpoint. So, I believe that AI workloads and government applications, those that are kind of require real-time data processing or decision-making, those are the ones that require low latency. And I think if you're working within a data center that has advanced interconnection solutions or options, right, that can provide that direct and high-speed connections between cloud providers like Google, leveraging telecommunications providers like Lumen and government agencies and other hyperscalers, you can help leverage that to ensure kind of a higher data transfer with minimal latency, all while within the data center environment.
And I wish I'm going to have you continue on this, Jim, because you mentioned a number of things, the interconnection of nodes and models and systems and so forth. From looking at this from a government buyer standpoint for a moment, I have a cloud hosting deal with Google, for example, and my applications are there. I guess if you would map out for this, the architecture, because of who owns what and who's connected to what, because I see these data centers popping up everywhere. They're not all Google. So is Google part of those data centers, and the fiber is another company, and then there are interconnection points, and then there are service providers over the fiber. Give us a sense of the chain and the layout of vendors involved here and how it all pieces together, because I think it's complicated.
It absolutely. So, Equinix merely began as a peering point for the telecommunication providers to peer their traffic and hand it off from one provider to another, 26 years ago. And that's how many data centers began, right? Primarily as a peering point. And as network service providers started to build outside their core network infrastructure inside of data centers like Equinix and other providers, we started to see these ecosystems start to develop within our four walls. Things like the financial segment, enterprise customers, and others. And then we started to see really the tipping point for us was when the cloud service providers like Google and others started to build their cloud on-ramps inside of data centers like Equinix. We have more cloud on-ramps within Equinix than any other provider on the planet. And then when you start to think about, Tom, from an interconnection standpoint, what you can do inside of those four walls. So if you're an agency and you have infrastructure inside of Equinix, right? Maybe you purchase that infrastructure through Lumen, right? Because we partner with Lumen and many other providers. So you build out an environment inside of Equinix, your carrier is Lumen. Well, maybe you want to have a multi-cloud solution. Well, inside of our buildings, you can connect to Google's cloud, other providers' clouds. If there's another agency inside of our four walls, you can also interconnect with them. You can interconnect with your SaaS provider, right? If you're using someone like a ServiceNow or someone other than that. So there's a whole host of things that you can do once you establish that kind of base core infrastructure inside of a data center, connecting to clouds, connecting to service providers, and really building out a distributed hub architecture as you start to expand not just your environment, but you're thinking about AI at the edge. That's where data centers come in to it. What we like to say is Equinix is oftentimes part of the solution, but we are not the only part of the solution. We work with many providers like Lumen, Google, and others. So hopefully that helps.
I thought that was a great entry, Jim, and I 100% agree. The partnership that we have with Equinix is certainly crucial and critical to allowing for that user experience to have that connectivity into the cloud service providers. And to Jim's point, Equinix is extraordinarily heavily involved in that peering arrangement, both between carriers as well as carriers and cloud. From Lumen's perspective, we consider ourselves the infrastructure that ties both the data centers together. We help provide those assets, those fiber assets in the ground that allow for that resiliency and that infrastructure. But to your point, Tom, or your question, it's really about what does that user experience look like? How does a user that's sitting on their handset or in front of their PC access that cloud? So if you think about Lumen as the service provider, that would be that end user that's sitting on either agency premise or even remotely in their, in their home office, allowing for that routed path to get to their point where the application resides, whether it's AI or cloud services. You would utilize the Lumen network for transmission. If there is a desire to get to a particular application that sits in a CSP or going into an AI environment, such as Gemini, that query would initiate through the Lumen network. we would then interconnect into the Equinix facilities to allow for that cloud exchange that then provides that application access into ultimately like the Google Gemini environment or any type of the Google workspace. And then that return path is also critical, right? Making sure that we have that same return path that matches the outbound path. And that's where that performance and that latency comes into play, to making sure that you have that viable experience that you're looking for, where you're touching your endpoint device and you see that immediate response. That responsiveness is crucial, that all network assets are in place and that all of our peering arrangements and agreements are intact with both the data center providers, the AI developers, as well as the on-ramps to those CSPs.
It's so refreshing to have a conversation about hardware. We almost don't do that much anymore. Jan, so Google is its own physical entity then. It's not inside those other data centers we see popping up. If it did, it would have Google on its name.
Well, no, Google leverages a lot of different facilities to carry out what we need to carry out. So some is on Google Concrete, some is in, other partner facilities that are out there in order to accomplish what we do. And just to make, one other point too, for Google to be successful, we rely on not only the folks on the line, but we definitely have to have that connectivity to the other clouds, because it's not realistic that, when we approach a customer and we're trying to solve a problem, that we say, well, just move every single thing you have ever to Google, right? It's not realistic. There's dependencies on other great technologies out there, whether it be Oracle or Microsoft or AWS. So what Equinix provides in terms of that multi-cloud connectivity is just as important to us as it is to the end consumer, because we can't do our job without that. At Google's, we design our solutions that we leverage those other clouds and the data inside those other clouds. And likewise, obviously the connectivity is super important, as we talked about.
Right, and the agency's own data center on premises, quote unquote, could be well also in one of those cages and not literally in their building anymore.
100%.
Why would you even want it? Why would you want that in your building anymore? I guess there's probably some. All right, let's move on here then. This is going to grow. Generative AI is not going back in the bottle, and more agencies and organizations are pursuing it. Maybe give us a rundown on what are some of the emerging capacity standards and interconnection standards that federal buyers need to be aware of as the need for fiber bandwidth keeps growing.
Sure. Do you want me to take that first?
Sure, go ahead.
So, what we talk about when we talk to customers, entities, government entities, enterprise customers, they face kind of a plethora of mounting challenges as they start to think about their AI workloads and evolving their infrastructure. So they're really kind of, I'd say 5 or 6 kind of key things to consider around this. And the first is around investing in AI-ready data centers. Tom, you started to talk about this, or alluded to this in your last comment. As these compute demands become greater and greater, right, the need to be able to keep pace with the advancements in liquid cooling, high power capacity racks and other things, really makes it challenging for agencies to keep pace with that level of investment that you're seeing within industry. So I think one is investing in AI-ready data centers. Jan started to talk about number 2 is around leveraging hybrid multi-cloud, right? So to give yourself that flexibility and scalability for AI workloads, some workloads are better in some clouds versus others, and really agencies are going to use probably at least 2, if not more, different clouds. So being able to leverage hybrid multi-cloud is really important. I think number 3 is around prioritizing security and compliance. So things like data privacy and regulatory and data sovereignty and those types of things you need to be mindful of. The 4th, Jan talked about that, around really deploying high bandwidth solutions, to connect your facilities to your data center provider or to other providers, as well as that interconnection aspect. I think sustainability is always kind of top of mind. We're investing in that. And then anything you can do to future-proof your infrastructure, right, to handle AI applications, I think is really something to be mindful of. So those are the kind of top of mind ones.
Okay, yeah, I wanted to get a little bit even more into the weeds though, too, with what is the current standard for how much, how many megabits and terabits per second, what are the emerging standards, what's going on that front that people should be aware of, again, and that idea that Jim mentioned of future proofing.
So I'll if you're okay, I'll jump in on that one. This is kind of exciting for Lumen. Certainly, you're always limited by the ability to transmit the data and the cards that are available, and the fiber, again, as I had mentioned before, able to support the expected capacity. Historically, we've been operating between at 100 gigabits per second and 400 gigabits per second in an optical wave environment, which if you talk about how you transmit data, this is what's considered as a layer 1 transmit. It's basically light. It's passing light from one endpoint to another and allowing for that traffic to flow. Our recent announcement that we've actually made public is with our partnership with Ciena and utilizing our new ultra low latency fiber assets, we were able to actually pull a 1.2 terabit per second data flow over a 3,000 mile span. That's the highest we've ever seen in the marketplace, and certainly over that particular distance that set a record, both with in the marketplace and also with our partner Ciena. That's the highest capacity that they've seen transmit over such a long path. So we're at the point now where you have what's called ITU standards, International Transmission Units. And that ITU standard that you follow, where we were at the 400 gigabit per second limitation, now moving to that 1.2 terabit per second, will allow for just a single wave instant. And you can have multiple wave colors on a single fiber strand to have multiple 1.2 terabyte flows going across between two data centers. That's an immense jump that allows for, again, that AI adoption on that back end, as I was saying, as the machine learning and the AI workload is actually taking place. Now we're greatly minimizing the throughput limitations that have historically been in place with that new capability and that new technology that's coming forward. So yes, it's a recent news announcement. We'll certainly be putting that into production over the course of the next 3 years. And hopefully by 2028, you'll be able to see, we'll be taking that with our overall fiber expansion that we're putting forward with both our end users as well as data center to data center connections. We're looking to have roughly 16.6 intercity fiber miles increased capacity in this next year, with a total of 47 million fiber miles between now and 2028 to allow for that full interconnectivity and that fiber capacity between the data centers.
And by the way, just out of curiosity, the fiber that can handle 1.2 terabytes per second for 3,000 miles, is it as big as a straw? Is it as big as a garden hose? Is it as big as a culvert under a road?
So the fiber itself is about the thickness of a strand of your hair. But the conduit that it's sitting in is going to allow for many, many, many of those fiber strands to be sitting. So you're talking about somewhere to the size of, I'd say you take a tennis ball can would be about the size that you'd be placing hundreds and hundreds of fiber strands, all capable of that 1.2 terabit per second transmission to be able to support multiple data center infrastructure.
All right. Well, yeah, it sounds exciting. It's a good thing we still have people majoring in physics in the United States, because eventually that's what you're getting into. And Jan, so how does a Google keep up with that? Because that's not your business, is transmission, but you have to be ready to terminate those things.
Well, we drive the demand that makes them have to go build all this stuff. So yeah, so from a Google perspective, the applications and what Google uses, and when I talk about Google, there's kind of two. I represent Google Cloud, but there's also the larger Alphabet, that runs a significant infrastructure, right, that supports the big applications that a lot of folks on this call are probably familiar with, Google Maps and Gmail and those type. At any given time, we have maybe 2+ billion users on this infrastructure. So I know the detailed planning is taking advantage of now 400, just like Campbell said, now 400 gigabit is available and stretching into terabits of data. Google also not only designs that and how our applications will run, and then how we can provide the correct user experience to all those users, but then also like how do we help, co-invest or invest in some of that infrastructure across the globe to make sure it's resilient. So, we definitely participate in investing in laying subsea cables alongside of our service provider partners and providing, financial capabilities there sometimes, different levels of participation depending on where we're going, in order to keep that terrestrial infrastructure massively resilient, kind of no matter what's going on in the world.
Yes, and so let's just add to that about the fiber. What do people need to do with their infrastructure in order to be able to take advantage of these emerging standards for speeds? Because the Cisco router you put in 1987 is not going to be able to handle the termination, I'm imagining.
That's true. Campbell, you want to take that one?
That's perfectly fair. So, it depends on the anticipated load and the intentions that you have. If we're talking about a layer 3 network, and again, as I mentioned, layer 1 is the fiber asset itself, right? The physical infrastructure. You move up to layer 3, that's your IP capabilities. That's really that endpoint device. We're talking over an IP-enabled network today. So as you're looking to increase your overall capacity, you certainly want to make sure that you have the right tech refresh in place to allow for that capability to be able to have that expansive reach. And when I think of, what we're seeing in the marketplace, even right now, we have the return of office that's taking place throughout all of government. That return of office, you're seeing that there's insufficient capacity in a lot of these areas. It's going to be requiring an additional investment, both from the routing infrastructure, your switching infrastructure, and making sure that you have the right capacity in place to be able to allow for the users that have come back to office to have that experience that they expect, the ability to go out and reach out to your cloud service providers, your cloud applications, your AI platform that either may be privatized or public AI. You absolutely need to make an added investment for that added load, a number of resources that are coming in, working in these common environments, common spaces. So yes, you certainly want to look at your layer 3 infrastructure, your routing infrastructure. Layer 2 is your switching infrastructure, making sure that you have that capability of both resiliency as well as throughput and capacity that's expected with this overall surge in demand. And then from the layer 1 perspective, making sure that you're on fiber. Your goal is to move away from copper. You have significant limitations, both from distance spans, as well as the overall throughput that's available to you. Moving to a fiber asset as quickly as possible will certainly ease that overall transformation that's taking place through that return to office environment.
All right, so you have some homework to do, basically. I mean,
A little bit of work.
Planning is really something agencies have to do on their own as part of this. And just since things are changing in the procurement world, we should detour a minute into what are the vehicles, the contracting vehicles, and what are the methodologies you think are most promising for agencies to ensure that their own infrastructures are ready for this influx of AI that they themselves say they want to bring into their agencies. I mean, EIS, is that still a thing?
That's very much a thing. I don't mean to hog the scenario, the environment, but certainly we operate in very expansive number of contract vehicles in the government market space. EIS is the predominant for the federal space. So yes, that's where you can buy all of the assets and the capabilities to allow for this on-ramp capability, again, through our partnerships with Equinix, heavily integrated into our EIS portfolio to allow for that cloud switching environment. In the EIS language, it's called CSPC. It's our cloud service provider. I forgot what the C stands for, but it's the capability to allow for that cloud interconnect for that WAN transport functionality that you have. So we have a myriad of agencies that are in place today. EIS is a contract vehicle that's going to be around for another 10 years. So heavily encouraged, if they haven't adopted yet, you certainly have that placeholder through a GSA sponsored contract vehicle to allow for this on-ramp into that cloud environment. And certainly Jan and Jim, I'll let you speak to other agency methodologies to be able to obtain and seek cloud services and interconnections.
And before you guys speak, and we'll get right to it, you might want to talk about how your partnerships can enable that, because there's no point in selling a service to the government if it's not able to be deployed in a way that's going to work. So go ahead, Jan.
Okay, yeah, absolutely. I mean, EIS is, I think that, Campbell said it, that's the right way. I mean, we partner with Lumen. We have peering points with them. So we have peering points with other service providers also. So that would be, your contractual front door to access Google and access, Google's cloud environment and Google's cloud infrastructure. So that's certainly the way. There are cloud contracts. There's like the Joint Warfighting Cloud Contract for Department of Defense. If that contract is being leveraged, it's really very similar. We're still going to work with partners like Lumen to provide the capabilities through that contract. So it's really no different than going through, from that perspective, than going through EIS.
And I think for us, Tom, there's a couple ways, right? So as Campbell mentioned, we are partnered with Lumen. We do work with Lumen. EIS is absolutely an option for customers who want to access Equinix services such as interconnection. We do also have a GSA schedule, but the vast majority of the work that we do is through partners, right? Whether it's on EIS, or let's say you're an agency and you put something out that's to the FSI or the system integrator community, we work with the GITs, the Lockheeds, the et cetera. So, as I mentioned at the beginning, we're often part of the solution. We're not the only solution. So we can plug in with, whatever provider you're working with, or whatever integrator you're working with to help deliver the services that you need.
But it's fair to say that agencies, any client, needs to make sure that their technology stack is there if they're going to take advantage of what AI can offer. And if they don't, it sounds like at best, you'll end up with a lot of latency. At worst, you could just clog your network to a halt.
Yeah, I think, Tom, it's a really good point. If you're as you're starting to think about AI at scale, right? I would say there are very few agencies that can keep pace with industry in terms of the level of investment that we're making inside of our infrastructure, right? So when you think about access to some of the network technologies that Campbell mentioned, you can do that a heck of a lot easier if you build that private AI model inside of a data center like an Equinix and leverage a multi-cloud environment, which Jan talked about as well. So I think that's first and foremost, right? Initially, certainly you can do it on-prem, you can do it in the cloud, but as you scale, you're going to need to put that infrastructure somewhere that can keep pace with the demands.
Right.
That's a great point. And again, that's that back end, right? So making sure that the AI systems have that ability to scale within the data center environment. You as a user obtaining information coming from what the AI platforms are generating, that's a very minimal subset of and a minimal amount of the capacity that's being utilized. And that certainly allows for that scalability that Jim's referring to. But the workloads in the data centers, have the users access that workload from the networks that they're residing in, utilize EIS as a contract vehicle to be able to obtain those particular services, allow for the managed service element of EIS to enable the agencies to offboard some of that transformational capabilities and understanding, and allow for the EIS providers to build that transformational path, and then maintain again that partnership that's in place on the back end of EIS between the Googles and Equinixes and the carriers such as Lumen to allow for that scalability and ultimately allow that transformation to come to fruition.
So just as you'll always need a handset, even though nobody builds their own telephone system and so forth, and we could make a million analogies, really it sounds like the way to go is this idea of infrastructure as a service, where your service level agreement says, I want to be able to have data, I want to have AI ability such that I need a minimum of 800 terabytes a second coming in. And then again, you've got to have the termination point in which to distribute it to your users and so on. But the rest of the infrastructure as a service or as an abstraction in terms of all the contracts sounds like maybe the way agencies ought to be thinking.
Yeah, I think so, Tom. I can even take it, kind of one step further than that. The way this AI is evolving, you can almost look at the large these large data centers that you referred to as AI power plants, whether they're from me or whoever's out there. And instead of dealing in kilowatts, they're dealing in this AI measurement called tokens, right? So all the providers are out there custom building infrastructure. Like we're talking specifically here about the networking side of it, but it could be the networking side, it could be the silicon diversity. There's a lot of techniques around that. How we handle encryption for privacy there at massive speeds, right? That's a whole nother topic. But you're pulling that all together to have really bespoke infrastructure that's able to provide the capability that a lot of us are using on our phones and everything today, but provided at scale in the enterprise the way they need to do it. That's so you want to be thinking about, now that I can get this in the hands of every single one of my functions inside my agency, right? I want to be aggressive about how I make sure that infrastructure is ready to handle all that.
And we have a question coming in from Wes here. Wes McEwen, thanks so much. I've seen some longer downtime from maintenance windows being extended and more frequent, as it seems like different interconnects and localized contracted providers are scrambling to catch up with the infrastructure. I guess that's kind of what we've been talking about. There's a national infrastructure and international infrastructure, 3,000 miles of fat cable, but then everything is local ultimately where you sit and have to see it. So they're scrambling these localized people scrambling to catch up with the infrastructure. In the larger market, investing or in partnering with smaller interconnects has to provide this kind of speed, accessibility. Anyway, I guess the sense of the question is, how do you get this to a local level with some efficiency?
So maintenance windows are painful, and admittedly, it's a challenge, specifically in the space that we operate in, right? We're always trying to strive to both maintain performance and availability. We want to be able to ensure that we're building out a resilient network. But as everybody can recognize, even if you're sitting on a Windows PC, you're probably told over and over again, your PC needs to restart due to some sort of maintenance activity. Similarly, as we're building out new technologies and features and wanting to enable them across our network, there's extensive testing, we call it regression testing, that has to take place to ensure that when you perform this particular upgrade, that particular device and that network is going to perform the way that you expect. Many times you're going to see that there are challenges, and there's certainly extended time periods that will lead to that downtime, specifically localized downtime for end users that might be impacted by a device that's under that maintenance window for that upgrade of service. Or sometimes you may actually see some card augments or something else that's taking place. Intent is always to improve the performance, improve the capabilities, access to the network. But in fairness, Wes is exactly right. You are going to see some instances where these maintenance windows are extended. Not every maintenance is going to plan. And so we want to make sure that we have the ability both to troubleshoot and triage along the way, and worst case scenario, the ability to roll back in the event that we're unsuccessful. And from an end user perspective, that doesn't always lead to the best experience. So we as Lumen at least always try to ensure that anytime that there is an impact that may take place, that we're very proactive in sharing that, hey, there is an estimated downtime that we're going to be seeing, and working with agencies and customers to try to minimize and at least pick the right time for that maintenance period to minimize that overall impact for the end user constituents.
Yes, because there are times of the day still when activity is low for many, many applications, especially in government that might be public facing. For the occasional, 3 a.m. tax filer, that's when.
And these days, with all the internationalization and globalization of networks, there's no such thing as a very, a safe window for a maintenance window. So historically, look at between the hours of 2 a.m. and 5 a.m. Well, if you pick 2 a.m. to 5 a.m. Eastern time, and somebody's over in London trying to access data on a financial transaction, they're in the middle of their business hours, and we have a maintenance window that's off hours over here. So yes, there's always going to be impact associated with maintenance and trying to continually improve the service offerings that we provide to our customers.
And that brings us to another question online, a good one, about this idea of purchasing some of this as a service that we mentioned a few minutes ago. He said, The question from Kevin Gallo is, what are some examples of how the services would be defined? Would it be, say, increments of bandwidth from a site with defined SLA parameters? I mean, what do you buy and how do you set up your requirements, I guess, really is the question. Jim?
Yeah. I can't necessarily comment on it from a network connectivity perspective. And this is just from my point of view. I think doing it from a GPU as a service, right? There are some companies, there are some providers like Lambda and others that provide that. I don't know if that has really been something that has been widespread across government necessarily, because the as a service model can get expensive, right? In some cases, it is more cost effective if you're going to build out, an AI environment, to build it to your specifications, leverage hybrid multi-cloud to pull in different data sets and configurations from other providers. There are options. I think, Jan, you started to talk about it around a lot of these data centers are becoming these AI factories almost, right? And there are providers who do this on the commercial side. We announced at NVIDIA GTC that Equinix is the first to offer their new DGX SuperPod with Blackwell GPUs, kind of pre-configured in 45 of our markets around the globe in our AI-ready data centers, right? So there are advantages. You're not purchasing it as a service, but depending on your requirements, you can purchase kind of pre-configured SuperPods in this case, for your requirements. The as a service component, again, for AI, I think a little bit harder to do, at least at this. Just my opinion.
Yeah, I should probably jump in since every single thing Google Cloud does is as a service. So
I meant on private environment, Jen, not in the cloud.
No, but it's 100% valid, Jim. 100%, like what you said, and it's everybody's involved, right? So so from just an as a service perspective, I mean, it's a little bit of a paradigm shift when you're engaging with a cloud provider, whether it's me or the other cloud providers that are out there. We're providing a service level agreement as part of that contract, and we're going to meet that service level agreement, right? So we have a service level agreement that typically right out of the gate is 4 nines, as we call it, 99.99% available. But there's ways to get higher than that, and then we do that at the gate, whether you're buying a GPU that you're using as a service with Google, a TPU, storage, and even networking. We have networking part numbers on our price list also. So it's a matter of how do you, in this hybrid environment that Jim talked about, that we're all in, it's a matter of how do you leverage his infrastructure at Equinix with DGXs around the globe with the SLAs he's going to provide you, which will be good. And then the cloud SLAs between, Google and other cloud providers, and put that whole picture together for what you're trying to accomplish.
Sure. And as pieces of the infrastructure get traded out, how can the agencies be sure that they're still getting the zero trust that they want? Because when you replace a device, you're replacing an IP address, you're replacing that which is calling on the next thing down the line to your data and your applications. And so you want to inherit those things. What's a good strategy to make sure you can inherit your zero trust and whatever cyber measures you have in place as pieces of your infrastructure get traded out?
Yeah. Well, we need another hour, I think, Tom.
Opening up a new can of worms. I do want to follow up on Jan's, so Jan, certainly with Google, significant amount of how they operate as a service. There is a capability as well. We talk about network as a service, and that's a functionality that does exist in the marketplace. Now, it's not prevalent in the EIS landscape, not to say that it cannot become prevalent, but that similar functionality, it is a pay by the drink model that you can utilize within your network. If you think about tying in an entire network infrastructure, say, take a larger agency with 2,000 or 3,000 endpoint locations, you can actually just build out a full consumption-based model with no early termination liability. And it's basically you're only paying for the capacity that you use. You can either pay for it site by site, or you can have pooled capacity to say, hey, I want 50 terabytes per month of overall data utilization. we open up all the pipes at all the locations, and it's now incumbent upon the agency to be watching the amount of usage that's going across that network. And then there's the bill that would be incrementing that goes along with that usage model. So there are network as a service capabilities that could be considered from agencies if they're wanting to make that leap into a more the as a service versus the fixed rate models that most of them operate in today.
All right. Anyone want to tackle the cyber question in the 60-second version?
I'll give it 60-second. It's a big challenge. It's not an easy answer. Zero trust never is an easy answer. I'll give you a data point as to, Google made a large acquisition or intent to acquire Wiz about, I guess, 4 weeks ago. And, it was a very large acquisition for Google. And a lot of it is the technology that Wiz provides and pieces to tackle this problem. Like, how do you maintain your zero trust in a hybrid and multi-cloud environment? So if you're on premise or in an Equinix facility with DGXs, you might be in your own data center. And then you're also leveraging Google and Amazon and Oracle and maybe Microsoft all at once. How do you have that maintain that security posture? Wiz is the reason why we spent the money and went after it, is to help tackle that problem. But there's certainly many other foundational techniques to do that, right? Encryption everywhere, sometimes multi-levels of encryption to maintain zero trust, and different technologies that ensure that people are who they are and where they are, and things of that nature when it comes to endpoint protection. So I think it's the 60-second version there's a lot going on to help do that, but it's still a difficult problem to solve.
And I think from a data center standpoint, we're very much from a physical security standpoint. So the cyber aspect of it, or the zero trust, that would be something a partner would provide. And just to add one other thing, Tom, when I mentioned the announcement we made with NVIDIA, the important caveat there is that we're not delivering that service directly, right? As I mentioned earlier, we leverage partners. So that could be a Lumen who is providing that service inside of an Equinix data center, where it might be accessing Google's cloud. So again, it's all about partnerships. And I think that's really how government benefits, is when industry comes together to leverage the best of breed from a lot of different places.
And it seems like in recent years, we've taken for granted that capacity is just always going to be there. That was kind of the idea of scalable cloud. And Jan, you mentioned the storage needs for even consumer type things like Google Mail. I'm 73% of mine after 15 years of never erasing anything.
We appreciate it, Tom. We appreciate that.
Somebody's maintaining something in a cloud, and all my pictures are 3 different places like everybody else's. But in reality, for fiber, you do need, as an agency, to do some capacity planning, because this stuff doesn't get built out and deployed just at random and at will, does it? I mean, the industry has to keep up also.
100%, Tom. I did want to just follow up with Jan's commentary about zero trust architecture and how it integrates with AI. Just to kind of close one part out, what I'm so appreciative of zero trust establishment is, we call it the east-west lateral movements are now minimized. And what I mean by that is, you have known traffic through known users that are authenticated, needing to get to a known endpoint that's authenticated. And that allows for that data integrity to stay intact. The east-west, that lateral movement that would be taking place, is basically that LAN infiltration. There can be other malicious users sitting inside of your network, that the zero trust architecture establishment maintains that level of data integrity. And so data integrity is crucial, certainly in the world of AI. As your AI algorithms, you want them to be able to utilize clean data as well. So you want to be able to have those levels of controls within your environment as you're establishing that zero trust architecture, to make sure that your AI data stays clean as well. Now, to your other point about infrastructure and preparedness, yes, admittedly, putting fiber in the ground takes a while. And that's why we're overpulling everywhere where we're going. to ensure that once we have that facility, in this case, we're talking about data centers lit, that it's not just going to be providing one capability for one particular entity within that data center, that overpull will allow many, many entities, whether it's in the marketplace from large enterprise customers or even in our government space, that they would have also access and visibility and to connectivity utilizing those added strands. But we want to make sure that we have that footprint everywhere, and being able to have that reach down to the end users is also admittedly a challenge. It's not always going to be fiber that we're going to be delivering to every premise, but we want to be able to get every user as quickly as possible onto the network. That may include other technologies such as 5G incorporation or even low Earth orbit satellite capabilities to bring you into that landscape.
And future capacity is going to be readily available, or is it spoken for?
I would look at it this way, Tom. And this is, I firmly believe, like, this is a super benefit to the federal agencies that some are represented here today. You've got like an Olympic team of providers here in the United States. I mean, between whether it be Lumen, who's on the phone here, Equinix, some of that aren't on the phone, like an AWS or Microsoft, Google, obviously, or we're all making investments today to, of course, satisfy the commercial, but I mean, we're all patriots and we want to make sure that the United States is also taken care of. So there's really, I really firmly believe that it's an Olympic team of companies that are put together. We've called it partnerships. I'm a coach, so I like to call it teams maybe. It's just a team that's going out there to make sure this is all happening for you. And I think we would all collectively say we want to help all the agencies take advantage of it.
Okay, well, we'll make that your final comment. We are coming to the end, and we'll give Jim and Campbell a chance to wind up also. Thanks so much.
Sure. So just in 30 seconds, Tom, I think there's two key data points that I like to call out. This was in a CBRE report. From a data center perspective, there's less than a 2% vacancy rate within North America, and roughly 80% of the capacity that's coming online over the next 5 years is already pre-leased, right, by enterprise customers, hyperscalers, and others. So when agencies start to think about this need, right, in the short term and long term, it requires planning, right, and collaboration. So I think those are a couple of things I would call out as you start to think about the short term, midterm, and long term. Start to think about those capacity requirements. Start to think what you need. We are investing for that wave, though, absolutely.
All right, sounds like the world's biggest Taylor Swift concert coming. If you don't have tickets now, you'll buy them one way or another, and it won't be cheap. Campbell, final word.
So I love the closing statements from both Jan and Jim, and certainly from Lumen's perspective, we absolutely are here to support every agency's mission. We want to provide the capabilities for agencies to be able to obtain the services coming from Equinix and coming from Google and other carriers and other providers. So those partnerships are crucial. And Jan said it best, right? We're all a team in here. Yes, there's a competitive landscape and a competitive edge to us, but we're all here serving the greater mission, which is to really support the overall public sector, whether it's DoD, our intel space, or our civilian agencies, as well as our legislative and judicial branch. We're all in this together, and we're here to continue to drive our own performance and continue to invest from a company perspective to allow for those transformation capabilities to be extended into these agencies and marketplaces.
Well, thank you all very much. Really great panel. We'll give them a virtual round of applause. And now I will turn the program back to Richard Zelkowitz. Thank you all very much.
Thanks, Tom. First,
Thanks,
I
Tom.
want to thank Tom, Jan, Jim, and Campbell. I thought, personally, this was an excellent presentation. I certainly learned a lot. And now, just for the rest of the participants on the phone, thank you very much for joining. And the last thing I want to leave you with is, please join future of these presentations and consider participation in other ways into the NNT COI. It could be in helping to work on future projects or future presentations, or it could be on actually serving on the leadership board of the NNT COI. By the way, that the current term ends on June 30th, and I know that there will be announcements about that soon. So I want, lastly, thank everybody again. I thought this was a great presentation today, so thanks.
Thank you all.